Okay, are we ready to try some example problems? Good. So we have an environmentally friendly 2,000 square foot home, which is 99% airtight. It costs about 8% more to construct than a conventional home of the same size. Most of these green homes can save 15% per year on energy expenses to heat and cool the living space. So what we want to know is for a $250,000 conventional home with annual heating and cooling costs of $3,000, do the future savings in heating and cooling costs justify making the home green? So we're told we specifically need to use a benefit cost ratio to do this analysis, and we're going to assume a discount rate of 10% per year and that the expected lifetime of the home is 30 years. So to start out, what I'm going to do is just go through the problem and identify all the information that I have. Okay, so I'm told I've got 2,000 square feet and it's 99% airtight and a 15% savings per year. So that's all the information about the kind of economic assumptions that we should make between these two types of houses. We're told that the cost of the conventional home, the initial investment I, is $250,000. And so therefore, for the green home, where we're told that it's 8% more to construct, the initial investment would be $250,000 times 1.08 or $270,000. And the heating and cooling, which is going to be an annuity in this case, we're told it's an annual cost, that's the same. So that annual cost is $3,000. In the conventional home, we're told that we get 15% cost savings per year on the green home. So in that case, we'd have 3,000 times 0.85 or 2,550 as our annual expense in the green home. We know that this is a cost alternative. Both of the homes, we're just looking at the cost of the initial investment and the cost of heating and cooling. So when we're thinking about this as a benefit cost analysis, we're considering the difference between these two projects, where the baseline is going to be the cheaper one, so the conventional home. And the way that we're going to proceed is to take the difference between the initial investment, and we're going to frame the benefits as being the cost savings that we get in the future from going green. So that's our alternative. And so our difference is that our delta in the initial investment is 20,000, and the delta in our annual cooling and heating expenses are 450, and that's per year. That means that the present worth of the green cooling and heating expenses are going to be 450 times P given A. We're told to use a 10% discount rate and to assume 30 years. So that's 450. We can use our lookup table to find this as 9.4269. And that comes out to be 4,242. Consequently, our benefit cost ratio is going to be the delta in heating and cooling costs, that's our benefit, divided by the delta in the initial investment, because we're doing an incremental analysis. So the benefit cost ratio in this case will be our 42 divided by the $20,000 difference in the initial investment, which comes out to 212. So therefore, no, it does not make sense to go green. Since it didn't make sense to go green, we can ask how much would the savings have to be in order to justify it. So this sounds more like a break-even type problem. In this case, we have the incremental benefit cost ratio, and to justify making the home green, that has to be at least 1. We can take that benefit cost ratio that we had from the previous version of the problem, which was the present worth of our benefits divided by the delta in our investment, which we said was 450 times P given A at 10% for 30 years divided by 20,000. And we want that to be greater than 1. Well, this 450 was what we had in the previous problem of what we would actually save. But because we're now doing this as a break-even style problem, this is what we want to solve for. So we're going to allow this to be our variable. So we're going to get rid of that, and we'll just call that x. Now, that means that x times our P given A factor has to be greater than 1 times 20,000. Therefore, that means that x needs to be greater than 20,000 divided by that P given A factor, which from the lookup tables we found was 9.4269. And therefore, that comes out to $2,122. Now we can ask a couple of conceptual questions. First, if the expected life of the home was 50 years instead of 30, would the annual cost savings required to have a benefit cost ratio greater than 1 go up, down, or stay the same? If the expected life of the home was 50 years instead of 30, that means we have more years for that annuity to accrue benefits. So we need a smaller amount for each individual year. So therefore, the annual cost savings that would be required would go down. Next, if the discount rate was 8% instead of 10%, would the annual cost savings required to have a benefit cost ratio greater than 1 go up, go down, or stay the same? If the discount rate was 8%, that means that we're discounting future benefits less than we were before at 10%, and so therefore the value of those benefits is going to be larger, which means that a smaller amount of savings per year will still maintain the same benefit cost ratio as before. So therefore, the annual cost savings required would also go down.